different types of factoring. So the process that we are doing, make sure that this is, okay, good, we are recording. Okay, so the factoring that we're doing and the process that we're going to do is still staying the same. Because as we saw 2 days ago where we had a greatest common factor, we pulled that number out, the process still worked the exact same. It didn't change. Even though the numbers are changing and how it looks changes, our overall steps are staying the same no matter what it is. Now this one here, 6x squared minus 15x minus 9 should look familiar because we talked about this the other day. This is the one we stopped on. Because we covered this yesterday. And when we talked about this here, well, we said there is a number that goes into all three, but it's not 6. It was 3, because 3 is divisible by 6, 15, and 9, and it works out that it is the biggest number that goes into all three. Because 6 divided by 3 is 2, and we have x squared, minus 15 divided by 3 is 5, and 9 divided by 3 is 3. So that is the biggest number that divides into all three. And this is where we stopped, because we realized, well, we don't have x squared. We have 2x squared. Because up to this point, the variable that was squared was by itself. Because all the ones that we've done so far has been just x squared or v squared or y squared. We did not have a number, well, other than 1 with our x squared. And that's the ones that we're going to look at today. Those are the ones that we're going to look at today. So, this will factor two sets of parentheses with 3 spaces, because our overall steps are going to stay the same. Now, when we look at this here, we need to determine the sign. Was our kind of second main step once after we wrote the 2 sets of parentheses with 3 spaces. So what would our signs for this be here? Negative and positive, because we look at the third term, which is -3. And if the sign of the third term is negative, the signs are opposite. So one of them would be positive and one of them would be negative. And the one that we pick as positive and the one we pick as negative, it really doesn't matter which one we put where. We just need to pick one, because again, at the end, we will check to make sure it works. Now we need to find the factors of the first term and the third term. Well, our first term right now is 2x squared, yes? Bless you. Even though we have 2x squared, well, the factors of x squared are still going to be x and x. That's not going to change. So whenever I factor these, I'll go on and put x and x, because I know x times x is the only way I can get x squared and this to work. Now let's look at the factors of 2. Well, what are the factors of 2? And that's it, yes? 2 is actually the smallest prime number that we have. So that's the only factors we have, yes? Well, if we only have one set of numbers, we can just put them in, yes? Do we want to put the 2 in the first spot or the second one? It doesn't really matter. We can just put it in one of them. So we're going to put it in there, and we'll check at the end to see if it's in the right spot. If it's not, we can always change it. Now we need to find the factors of 3. And that's it, isn't it? So I just throw them in. If this works, awesome. If not, we either have to change the numbers or change the signs to see if it works. So any questions on this here before we check it? Well, x times -3 is -3x. 1 times 2x is plus 2x. And -3x plus 2x would be negative x, yes? Is that what we wanted? No. Okay. Now changing the sign won't work for this one here. Numbers. Because if we change the signs like we saw before, since we got negative x in the previous setup, if I flip the sign, we'd get positive 1x. Well, that's not what we want, because we want this to be negative 5. So let's try this setup here. X times negative 1 is negative x. 3 times 2x is going to be plus 6x. And negative 1 plus 5, or 5 minus 1 is, not 5 minus 1, 6 minus 1 is, I think I already said it, 5x. Is that what we wanted? Well, close. It has to be negative. We got the right number, but wrong sign, yes? Whenever we get the correct number, but wrong sign, we've switched the signs. So once we switch the signs, we got x minus 6x when we check it, which gives us our negative 5x, which is exactly what we wanted. Any questions on this here? So does having a number in front of that x squared really change anything too much? No, I mean, we'll have to check it a little bit more and be a little bit closer looking at it, but it's not really changing too much overall. Any questions on this here before we look at another one? Yes, sir. This one? Mm-hmm.
I make into a minus sign?
Yes. Mm-hmm. Yeah, since the third term is positive, the signs would need to stay the same. Because a negative times a negative would give us our positive, and a negative plus a negative would still be a. Mm-hmm. So let's look at this one here. Is there a number that will go into all three terms? Well, 2 will go into 2 and 12, yes? But will 2 divide into 11? No. So unfortunately, there's not a number that will go into all three. There's not a greatest common factor. So we'll look at our two sets of parentheses with 3 spaces. So we want to find the sign first. Now, we always look at the third term, and here the third term is, so the signs are the same, and they match the sign of the middle term, which is positive, because we have positive 11x, so our signs would be both positive. Well, now we need to find the factors of the first and third term. Well, 2x squared, well, I know that factors of x squared are going to be x and x, because that'll be nice. And what are the factors of 2? 1 and 2. Which do we want to put the 2 in the first or the second one? Doesn't matter. Where do you want to put it? Second one? Yep. Because we're just throwing them in, because again, our last step is to check it. Because this is guess and check, plug and check. We're just plugging them in and checking to make sure it works. Now the other one we want to find the factors of is 12. So we'd have 1 and 12, and then so out of these 3 sets of factors, which one do we want to try? 2 and 6, which one goes first, which one goes second? And 6 would go second. x times 6 is 6x. 2 times 2x is plus 4x, which gives us 10x. So that's not what we're looking for because we want the middle term to be 11, yes? Okay, let's try 3 and 4. Which one goes first? And we'll check it again. X times 4 is 4x. 3 times 2x is plus 6x. Well, that gives us 10x, yes? Well, there's one thing I want to look at with this here. So in the second set of parentheses, does 2x and 4 have a greatest common factor? 2 is in common with both of those, yes? So technically, if I wanted to, I could pull the 2 out of those two terms, yes? Now, what's interesting with these here is if there is a greatest common factor here and we don't pull it out, then there would be one in here. But is there a greatest common factor to begin with? So will there be one in either one of these parentheses? Well, no. So that means 2 and 6 cannot share the same spot. 2 and 4 cannot share the same spot because they both have a common factor of 2. 2 and 2 cannot share the same spot because they have a common factor of 2. Does that make sense? Because can I factor a 2 out of here? Because, well, here we know this doesn't work. But here, there's a common factor of, which means if this worked, I could rewrite this as x plus 3 times 2 times x plus 2, yes? Which means it would have been 2 times, which means there is a greatest common factor of 2. What did we say at the beginning? 2 does not divide into all three terms, yes? So that means if there is no greatest common factor to begin with, there cannot be one in any of these here. Because if there's one in one of the sets of parentheses, it means we can pull it out. If I can't pull one out at the beginning, I cannot pull one out as a factor. If there's no greatest common factor to begin with, the parentheses cannot have one either. But it will also not work if it doesn't have one. So here, as we saw, this gave us 10x, yes? Let's flip them. Let's flip the 3 and 4 and see what happens. X times 3 is 4 times 2x is plus 3 plus 8 is? Is that what we wanted? So this here is our answer, x plus 4 times 2x plus 3. Because, I mean, it will match up to the equation. I just didn't do the whole multiplication out. Because x times 2x is 4 times 3 is. And the reason I don't do x times 2x or 4 times 3 is where did I get the x and 2x from? 2x squared. I got it from the first one is the factors of the first term. Well, but we don't have to do that check. Because x times 2x should always get me back to 2x squared, yes? Because that's where I got them. The factors of 2x squared, they should multiply back together to give me what I started with. The 12 should, 4 and 3, they should multiply back together to give me 12, yes? And the ones that we've done so far, those two always came out every single time, yes? The only one that's always different is the middle terms. There's the ones that are changing depending on the setup, yes? So those are the ones I check. If I know x times 2x is always going to give me 2x squared, and 4 times 3 would always give me 12.
Do we always have to do it that way?
I mean, if you want to multiply all the way through, go for it. I do it this way because since I know that those two would always give me the first and third term, I kind of push them to the side and focus on the one that does change. Because if I can do it in less steps, I'm going to do it in less steps. Let's look at this one here. I'll go on and tell you there's not a greatest common factor. The first one that we did is going to be the only one that we have on this or the homework for this one here that has a greatest common factor. I'm not going to throw both of them in or have you try to do both of them at the same time. Okay. 2 sets of parentheses with 3 spaces. So let's find the signs for these here first. So we look at the third term to see if it's positive or negative, and it is. So the signs are the same and they match the sign of the middle term, which is? So they are both positive. Now we need to find the factors of the first and third term. Well, what do I do know? One of the factors of the first term, well, the factors of the first term has to have what and what? And x, because that's the only way we get x squared, yes? Because anything I know that's staying the same in both of them, might as well go on and put it in, because I know those two first spots are going to have x and x. Throw it in. Now we need to see the factors of 4. We have 1 and 4 or 2 and 2. We have 2 different factors of 4. Logan, which one do you want? Let's do 2 and 2. So it really, I just need to pick which one I want. Now, the more that you do this and the more that you get used to doing these, you'll start seeing patterns that emerge. Depending on, okay, how the factors of the first term and how the factors of the third term look, and kind of comparing to the middle term, we can start picking them out. But picking between 1 and 4 and 2 and 2, really it's just a roll of the dice, or dealer's choice, what I want to pick first. So I pick 2 and 2. Because again, once we get everything plugged in, we always check it to make sure we have it set up right. So really having it correct on the first try is not the goal, it's trying to find it the correct one. If it takes a few times, that's fine. But we just pick them and see where to go. Now the factors of 35, well, we always have 1 times 35. Well, 2 doesn't work, 3 doesn't work, 4 doesn't work, but 5 and 7. So what factors of 35 do we want to try? 5 and 7. And now we're going to check it. Well, 2x times 2x will give us 4x squared. 5 times 7 would give us 35. So those two are good. So the one that we need to focus on is 2x times 7, which is 14x. 2 times 7 gives us 14. And 5 times 2x is, and this gives us, is that what we wanted? No. Okay. Now we can switch the 5 and 7. 7 and 5. Is that still the same thing? Yeah, it goes 2 and 2. So this here, because since 2x and 2x are the same, changing the 5 and 7 for this setup doesn't really change anything here. Do we want to try the 1 and 35? Well, as we notice here, these numbers added together, yes? And got bigger, didn't they? Is 35 too big? 35 is already greater than. So wait a minute, if I plug it in here, it's just going to get. So, well, plus and plus, we can't really change the sign. But there's one other thing that we can change, because we had 2 and 2 or 1 and 4. So we're going to switch out our 2x's to 4x and x. Now, if we tried the 1 and 35 with 2 and 2, we would get 71x as the middle term in either setup. So if we try this here, 4x times 5 is 7 times x is plus, which is 27. Well, it's not it. So if I switch the 5 and 7 now, do I get something that's a little bit different? Well, yeah, because now I'm not, since I don't have 2 and 2, I have 1 and 4. Now it's making it a little bit different, because 4x times 7, or 4 times 7, is 5 times x is plus, and 28x plus 5x is, which is what we wanted, yes? So this here is our answer. So sometimes it does take doing a few more, plugging a few more in. But this here is our answer. Any questions on any of these here? So a lot of plug and check, plug and check, plug and check, yes? Now, it's always good to check to see if there's a greatest common factor, but there's not. And one of the big giveaways is, well, 8 and 9. 8's 2 and 4 is divisible by 2 and 4. 9 is only divisible by 3. So there's not a greatest common factor. And it's always good to check to make sure. So what are our signs going to be? Both negative. Because our third term is? So the signs are the same and they match the sign of the middle term. Any questions on this so far? Now, we'll look for the factors of the first and third. So 8 would be 1 and 8 and 2 and 4. And I went on and already filled in the x's because we know x squared is going to be x and x. Now, do we want 1 and 8 or 2 and 4? Factors of 9. 1 and 9 or 3 and 3? 3 and 3. And let's get a fancy color. Right there. I think it is. I don't think I got to pick it. Yep, nope, it didn't give it to me. Oh well. 2x times negative 3. Negative 3 times 4x. Which gives us 18. Negative 6 minus 12 is negative 18. Is that what we wanted? So we can switch the 3 and 3. It would give us the same thing, yes? We could, yes. Now, would switching the 2 and 4 do anything? Well, because since the other one's 3 and it'd still give us the same setup. Now, if the signs were different, then possibly. But again, if I'm switching signs, If I'm switching these because the sign's off, then maybe. But really, whenever we have one number that is the same on both, flipping them doesn't really change too much normally. Because if I flipped it, it'd still be 4 times 2. Huh?
Well, I didn't switch up.
Yes?
Put 1 and 9.
You got smaller? Okay, so 2 and 4 and 1 and 9 don't work too well. So let's look at these here, see if 1 and 8 does anything. 8 times negative 3 would be negative. That is the vacuum. And negative 3 times x would be negative 3x. Well, negative 24 minus 3 is going to be negative 27. Is that what we wanted? No. It is closer.
It's a lot of stuff.
Okay. I'm going to go on and tell you 1 and 9 does not work. Because we're going to try this here with 9 and 1. Because we didn't try, because I'll tell you that 1 and 8 and 1 and 9. Well, 8 times 9 is 72. We cleared it. That's way up. The other way around is really just going to be 8 plus 9, which is going to give us 17. So this one here we didn't try. 2x times negative 1 is negative 2x. Well, that's a small number. Negative 9 times 4x. Negative 9 times 4 is negative 9 times 4. We'd have our x. Negative 2 minus 36 is? So one of the things I would do that what we did do here that I would stay away from is once you pick a number with x, so 2 and 4, let's stick with it until we've tried both of the other combinations, unless we know for sure it's not going to work. Like on the other one where we had 1 and 35, but we saw 35 was way too big, and we knew that they were combining, so we threw it out already. We knew that wasn't going to work. So here we needed to try 1 and 9 first to see. Now, if we'd flipped it, yes, we do get a smaller number, but here it worked out to be fine. Questions on this here? Because I think we have several more. Let's look at this one. Is there a greatest common factor between 10, 101, and 10? Well, 101, if it was 100, then yes. But 101 kind of throws everything off, yes? Yes. One hundred one, 101. All right, we need to figure out the signs that go in the middle. Since the third term is, the signs are the same and they match the sign of the middle term, which is? So they're both going to be positive. Now we need to find the factors of the first and third term. Well, with x squared, I know I'm going to have x and x. Now the factors of 10 are 1 and 10, or which one do we want to try first? Well, hey, the other number is 10, so we either have 1 and 10 or 2 and 5, yes? So what do we want to try first? 2 and 5. Will this one work? Let's find out. Well, 2x times 5 is 2 times 5x is, which is, didn't quite get there.
Hey, let's just switch them around.
So I'm going to switch one of them. If we switched both 2's and 5's, we'd get the same thing. 2x times 2 is 5 times 5x is plus. So we got a bigger number, yes? But barely. Okay. So I'm going to get rid of 2 and 5 and go with so let's try this one here. Well, 2x times 1 is 10 times 5x is plus. Well, that didn't work, did it? Well, the other direction would give us 25x, because 2 times 10 is 20. 1 times 5 is. Let's go on and rewrite it. Let's see it. Because if we do 1 and 10, well, 2x times 10 is 20x. 1 times 5 is plus 5x, which gives us 25x. Well, I've exhausted every method or every setup for having 2x and 5x, yes? So that means 2x and 5x are not going to work. We're going to have to use 10x and x. With our third term, do we want to go with 2 and 5 or 1 and 10? Okay?
Alright. So go 10 and 1. And then go 1 10. And then that's it.
So 10x times 10 or 10 times 10 is?
100.
So we'd have 100x. 1 times x is plus. And 100 plus 1 is 101x. Now I'm just going to throwing that on the ground. Any questions on this here? So a lot of this is just continuing to try different methods and different numbers. And the more that you do this, the more that you'll start seeing patterns of how it looks. Kind of what factors should I use or try first. Any questions on this here? I'm going to go the other way. Is there one of these here that we have left that y'all want to look at before we finish for today? 8? Let's look at number 8. 16x squared plus 40x plus 25. Well, there's not going to be a greatest common factor between these three terms here, so we can go on and start off with our The third term is, so the signs are the same and they match the sign of the middle term, which is, so the signs are both. Now we need to find the factors of the first and third term. Well, 16x squared, well, I know I'm going to have x and. Now we do need to find the factors of 16, which is 1 and 16, or 4 and 4. So which one do we want to try first?
About 2 and 8.
Okay. Now, 25 is 1 and 25, or 5 and 5. Which one do we want to try first? 5 and 5.
Where's that yellow hoodie? In this office?
All right, guys, let's check this here. Well, 2x times 5 is? 8 is, and 10x plus 40x is 50x.
Alright, keep the 5 and 5. But switch the. Yeah, switch the 2 and 8 to 4 and 4. No.
Yeah, 4 and 4 because 4 times 5 plus 4 times 5 would be 20 plus 20, so that's 40.
Mm-hmm.
But I was thinking that.
4 times 5 is 20, we'd have x.
5 times 4 plus x.
So this is the solution. So this here would be the solution. But there is something special about this here. Well, what are both sets of parentheses? They are the same, yes? So really, if we wanted to, I could actually rewrite this as 4x plus 5 squared. And this actually does have a special name, this type here. These here are called special, perfect square trinomials. Perfect square trinomials, because they can be written as a set of parentheses squared. And that's it.